graph and compare its linear function. Okay, so first we're going to define the slope, which is often called the average rate of change. So if you're given 2 points on a line, namely x1, y1, x2, y2, and we can calculate the slope, which we define by the variable m is equal to rise over run. And we calculate the rise by looking at y2 minus y1, and the run is calculated by the change in the x values, which is x2 minus x1, where we cannot divide by 0, so x1 cannot equal x2. Okay, so there's special cases. So when your values of x are equal, it means that you have a vertical line because there's no change in the x values. And if you have a vertical line, then your slope is undefined. Hence the division by 0 in the calculation of the slope. Whereas if we have a horizontal line, we have a run that's defined, but there's no change in the y component. So the rise is 0. Run can be anything we want. It can be infinity. And so the value of the slope is equal to 0. Okay. I always like to draw a little picture. So if we have x1, y1, and some other point x2, y2, you can break it down into the horizontal and the vertical components of our line. I should have drawn my original line. And when you look at the horizontal and vertical components, we can call those components rise and run. It's the change in the y values, the change in the x values. The little triangle is a Greek letter delta, which just means change of. You'll often see it in different scientific settings, the change of different variables. And for this, we would take the difference in the x values and the difference in the y values. So just a way to visualize where the definition of a slope comes from. Okay, now using that formula, we're going to calculate the slope of a line with these coordinates. Let's plot them. So we have the point 2, 5 and 0, 8. So when you plot your x and y components, your first value is your x value, and the second one is the y value. So we go along 2 units to the right because it's positive, and then 5 units up. So 5 is positive, and that is the point 2, 5. And then we also have 0, 8. So 0, and then up to 8. And we can draw a straight line that goes through these points. And we want to use the 2 points on that line to calculate the value of the slope. Okay, so we're not even getting to defining the equation of the line at this point. All we want to do is look at the slope. So we can look at our picture and identify the rise and the run. And if you're going up, then it's positive. If you're going to the right for a run, it's positive. Whereas if you're going to the left in a run, it's negative. Down for the rise is negative also, but we'll see how that works out in the slope calculation. So m is change in the y's, that's your rise, over the change in the x values. And you end up getting positive 3 over negative 2, which is negative 1.5. Okay. So we can see here, looking at our calculation, I'm really breaking down this one question into more detail than we need to, but starting from our initial point 2.5, the rise is defined as 3. So we have 1, 2, 3 units up. And the run is negative 2. And so you're going 2 values to the left. And if you wanted to plot other points on that same line, we start off from one of the points and we use the same rule for the slope to find other points. So rise over run and you'll get another point on the line. Okay, another calculation for the slope. M is equal to 1 minus -4 all over -4 minus -8. You can see here when I substitute negative values, I want to substitute in brackets to show that I'm subtracting a negative number, because that's often a place where students make, well, students and everyone make it's a common error. You can know what you're doing and still make a sign error. Okay, so we end up getting 5 over 4. So again, we can check that by plotting it. We have -8, -4 is my first point. And the second point is -4, +1. And we connect those using our straight edge. On assessments, I've seen students use everything from credit cards to student cards or whatever they have that is nice and straight to draw their lines. You can see mine isn't even perfectly straight here. Okay, so now we can calculate rise per run. So if we identify the rise and the run, whoops, I mislabeled those, let me fix that. Rise and run. So the rise to go from one point to the next is 1, 2, 3, 4, 5 units down. And the run is 1, 2, 3, 4. So what's interesting about the way that I just chose to label that, we ended up getting, so rise over run, it would have been -4 over, or -5 over -4, which ends up being 5 over 4. So if they're both positive, both negative, you get the same slope. The negative signs cancel out. So we've looked at how to calculate the slope of a line, determine the slope of a line, but now we're going to look at how to express a line as a written equation. Okay, so we have two different forms that we're going to be using in this course, the slope y-intercept form, which relate the line in terms of its slope and y-intercept. The slope is given by m and the y-intercept is given by b. And the equation of the line is y is equal to mx plus b. And then standard form, where we have coefficients and constants a, b, and c, and we write the equation such that it's all rearranged to one side of the equation and set equal to 0, and it's ax plus by plus c is equal to 0. Now we're going to look specifically at what x and y intercepts are. So x and y intercepts tell us where the graph crosses the x-axis, that would be your x-intercept, and the y-intercept tells us where the line or the function crosses the y-axis. Okay, so we would list those points. Notice here, this is the x-axis crosses at x equals 3, so your x value is 3 and your y value is always going to be 0 at the y-intercept, whereas for the, or sorry, let me start again. For the x-intercept, we're determining the value of x where the line crosses the x-axis and your value of y is always equal to 0. Whereas for the y-intercept, your value of x is always equal to 0, and you're determining the value of y where your function or line crosses the y-axis. Okay, so for this linear function, 2x minus 3y is equal to 6. There's only one x and y-intercept. And you can see graphically, looking at our graph, our y-intercept is 0, -2, and our x-intercept is 3, 0. And we define these as the point where the line crosses the respective axes. So your y-axis and your x-axis. So depending on the resource that you're looking at, some textbooks call x-intercepts different things, and because the x-intercepts are where y is equal to 0, sometimes they're actually called the zeros of a function. Sometimes they're called the real zeros, real numbers. At times they're also called the roots. It just depends on the textbook you're looking at. Okay, so here we want to determine the x and y intercepts for the following function. Y is equal to negative 3 over 4x plus 9. So we're going to look at the x-intercept and the y-intercept. X-intercept occurs where y is equal to 0. So we're going to plug in 0 for y in our original equation, and we want to solve for the value of x. Okay, to solve this function, we're going to multiply both sides of the equation by 4. Actually, I'm going to show the multiplication is just a dot so that you don't confuse it with variable x. This becomes 0. It's equal to negative 3x plus 36. So the whole reason for multiplying by 4 was to clear the fraction. If you are having trouble with solving linear equations like this, you can look back to the first part of the course where we looked at how to solve equations. Okay, so now we're going to bring the 3x to the other side. It becomes positive. And the last step in solving for x is to divide both sides of the equation by 3. And we find that x is equal to 12. With our y-intercept, it occurs where x is equal to 0. So we plug that in to our original equation, and we find that y is equal to 9. Therefore, the x-intercept is 12, 0, and the y-intercept is 0, 9. Okay, perfect. If you sub either of those points into the original function, they should satisfy your equation. So they should make left side equal the right side if you've calculated things properly. Okay, so practice now. I encourage you to pause the video, try it on your own, and come back to it and take a look at my solutions. We want to write the equation in slope-intercept form and identify the slope, x-intercept and y-intercept, and state whether or not the function is increasing or decreasing. Okay, so first of all, putting it into slope y-intercept form, our goal is to put it into y equals mx plus b form, which means get y by itself. So to get y by itself, we need to bring the x to the other side of the equation. And the last step is to divide everything by 2 to solve for y. So it's minus 1/2 x plus 3. Therefore, our x-intercept, or sorry, we don't know the x-intercept yet. Our slope is negative 1/2, and our y-intercept is 3. So this is slope intercept form. This is our slope and our y-intercept. Alternatively, you could also solve for the x and y-intercept. Well, we need to know the x-intercept, but you could solve for the y-intercept a different way. We could have solved for it by just subbing in x equals 0 into the original equation. So you get 0 plus 2y is equal to 6. Then you solve for y by dividing everything by 2, and you find that it's equal to 3. Okay, for the x-intercept, we want to find where y is equal to 0. So we have x plus 2 times 0 is equal to 6, and we find that x is equal to 6 is your x-intercept. And the last thing we need to state is whether or not it's increasing or decreasing. Because our slope is negative, it means that as we increase the value of y, the value of x decreases. So it means that our function is decreasing. Okay. Whereas if you had a positive slope, it would mean that your function is increasing. State the equation of a line with a slope of -2 and a y-intercept of 5. So we're given that m is equal to -2 and b, our y-intercept, is equal to 5. Therefore, y is equal to -2x plus 5. It doesn't state what form the equation needs to be in, so slope y-intercept form is just fine. Okay. In the next part of these notes, we look at various slopes and how to determine if a slope is parallel or perpendicular to an original line. So if we're given two equations of lines, so two different lines, L1, where it's equal to m1x plus b1, and a second line where we have y is equal to m2x plus b2, and we're told that if our lines are parallel, then it means that the slopes are the same. Therefore, m1 equals m2. Whereas if our slopes are perpendicular, then their slopes are going to be negative reciprocals of one another, and m1 is equal to -1 over m2. So you flip the slope and multiply it by -1, negative reciprocal, that's what that means. So we have two different practice examples. We want to write the equation of a line that is, first of all, parallel to y is equal to 2x minus 3, and then a second line that's perpendicular to y is equal to 2x minus 3. So looking at the parallel line, we know that the slope of our original line is 2, and therefore our parallel slope must also be equal to 2. And we can express the equation of the line now. So y is equal to 2x. 2x is a line that is parallel to our original line. 2x plus 10 is another line that is also parallel to our original line. And you can have any real number here. And as long as the number it's a real number, and we don't get into complex numbers in this course, but it is important to put that as a caveat here. As long as it's a real number, this actually describes a whole family of functions that all have the same slope but a different y-intercept. So if we were to look at this, you'd have your original line would cross at -3 and it would have a slope of 2. And the one I just drew would have a y-intercept of 10, so it would have the same slope, it'd be parallel, but it would go through 10. But you can take any line that has the same slope, any line that's parallel, and it would just have a different y-intercept value. So instead of having 10 there, you'd have something else. So there's an infinite number of correct final answers for that question. Okay, part B, we want a line that's perpendicular. So our original slope is 2. The perpendicular slope would be the negative reciprocal of 2, which is -1 over 2. Therefore, we can have y is equal to -1/2 x as one of the possible lines that is perpendicular to our original line, or any line with any y-intercept as long as the slope is -1/2. So I'll add this note here about that value as well. Now looking on the next page, we want to look at comparing equations, the table of values as well as the graph of the linear equation. If we have y is equal to 2x plus 3, I'm just going to write that out again, y is equal to 2x plus 3, we can look at a few different values of x. And one thing to note is because it is the equation of a line, you only need two different values on the line in order to graph it, because as long as you have two lines, you just connect them and you have your straight line. Okay, so when we plug in the values here, we get -1, 3, and 7. And we're gonna plot these. So at 0, we have 3, +2, 7 and negative 2, we have negative 1, and now we can connect those points. I encourage you to have your straight edge out, but it should be a perfectly straight line if you connect it properly. And we know that this is the equation y is equal to 2x plus 3. Now, looking at this, we want to consider how could you use the graph? So if you had the graph now instead of the actual equation, how could you use that graph to write the equation of the line? Well, don't forget, we know how to calculate the slope of a line given 2 points. So if we take a look at any 2 points that are identified on this line, we can calculate the rise and the run between those 2 points. This would be a run, we're going to the right 2 units, and then we're going up 4 units. So you could find m is equal to rise over run, which is 4 over 2, and then you get your slope of 2. And you can also read the y-intercept right off the graph. So from looking at that, we could say, well, m is equal to 2, our y-intercept, which is b, is equal to 3, therefore y is equal to 2x plus 3. And we're going to do just that. So if we consider this line shown, we don't have an equation for it as of yet, but we can determine the equation by looking at the values on the graph. It's always best to scan the line and determine where you can easily read the points off the line. And looking here, there's actually 3 different points. So at 8, 1, at 4, 4, and at 0, 7, we can read off the graph easily. Looking at it right away, we can see, okay, our y-intercept is equal to 7. Now we can determine our rise over run. So looking at this, if we start at 8, 1, our rise, we go up 1, 2, 3 units. And then we're going to run to the left 1, 2, 3, 4 units. So the run would be negative 4. And so our slope is equal to rise over run. And we have 3 over negative 4. Therefore, y is equal to minus 3 over 4. By convention, we usually move the negative sign up to the top. X plus 7. So if you're looking in the back of a textbook, that's what you will see. But it's not incorrect to show it in the bottom of the fraction. It holds the same value. Okay. Now we want to determine the equation of the line that includes the 2 following points. Using those 2 points, we can calculate the slope. So we know that m is equal to negative 1 minus negative 2. And the run is going to be 8 minus 3. So we get minus 1 plus 2 over 8 minus 3, which reduces to 1 over 5. Okay. So far, we don't know the y-intercept, but we can determine the equation of the line by subbing in the value for the slope and as well as one of the points. So now if we take either of those points, the original points, 3, negative 2, or 8, negative 1, and sub them into this equation with b, we can solve for b. It doesn't matter which one you sub in. So if you and your friend each sub in a different point, as long as that point is on the line, you will get the same value for the y-intercept. So let's say sub in a point to solve for b. I'm going to say let's sub in the point 3, negative 2. Again, it doesn't matter which one you use. Okay, when we sub that in, you get y. So negative 2 is equal to 1 over 5 times x, which is 3, plus b. Okay, let's solve for b. So we can simplify this. We get 3 over 5 plus b minus 2. So b is equal to negative 2 minus 3 over 5. Now find a common denominator. You get minus 10 minus 3 over 5, and the final answer is 13, negative 13 over 5. Okay, that's the final value for b. It's not actually our final answer. We need to have a statement where we state the equation of the line. So y is equal to 1 over 5 x minus 13 over 5.